Have you ever wondered how natural attractions on Earth came to be? Where mountains came from? Where the valleys sunk so low under sea level started? Have you ever wanted 100 extra points for science class? If the answer to any of these is yes, then you found yourself in the right place. Welcome to Landforms Result from Constructive and Destructive Forces. I'll be your host. Let's get started. As the very literal title suggests, landforms like mountains and valleys alike are created by way of forces, specifically constructive and destructive forces respectively. By the way, don't mind the shaky lines and demonstration doodles. Drawing and writing with a mouse is hard, and Windows Movie Maker isn't doing me any favors. Destructive forces tear down features while constructive features build up on Earth's surfaces. Pretty straightforward, right? We'll start by explaining destructive forces first. Weathering is pretty much the same definition as destructive forces itself. Weathering is the breakdown of rock, the driving term for destructive forces. Things that cause weathering, like water, wind, and ice, are called agents, or causes of weathering. All agents work together in harmony to slowly but surely wear down features into Earth's surfaces. Then, everything changed when the Fire Nation attacked. Moving on. Weathering that doesn't affect rock's chemical composition is called physical weathering. It's the kind of weathering the examples I gave earlier accomplish. Though chemical weathering does change the chemical composition of rock. They become a whole different type of mineral, or even a different type of rock. Things like carbon dioxide, oxygen, and water accomplish chemical weathering.
But wait just a minute! You said that water was an agent of physical weathering.
It is, but it's also an agent of chemical. It's both, depending on circumstance. Cool, right? Water is simple, but it can accomplish a lot. A rock's resistance to weathering is greatly based on its mineral composition. Physical and chemical structure alike determines how it reacts to weathering, its resistance among reactions. Some minerals may hold up better and last longer under the same conditions that would rapidly dissolve another mineral. Transitioning from destructive to constructive forces comes erosion. Erosion is simply the moving of weathered materials from one place to another after weathering. Once broken down, the material doesn't just disappear. If it isn't just packed down by extreme pressures, it has to go somewhere. Erosion is the process of this going somewhere, by way of water, wind, or ice. A bunch of factors contribute to the rate of erosion: weather, temperature, the type of rock, etc. For example, erosion happens faster on barren and dry land compared to vegetation-covered land. Erosion is not to be confused with mass wasting, which depends on gravity to move weathered material down slopes. That happens to be a different thing that I won't get into, because time restraints. Guess you could say deadlines will probably be the death of me. Ha ha, I'm suffering. Erosion, mass wasting, and weathering are all usually explained individually, like in this video. But they're better explained as overlapping processes. Honestly, both constructive and destructive forces intertwine and shape the land over time. It's just a matter of classification to those individual aspects of the cycle. In any case, that brings us to the final aspect of the cycle: constructive forces. As previously mentioned, constructive forces build up Earth's surfaces. They actually introduce some pretty new agents like crustal deformations and volcanic eruptions. Amazing. Also, the deposition of sediment. This is the stuff that was raped from those destructive forces. Like I said, it's gotta go somewhere. This is where it goes, being repurposed. Cycles, dude. Volcanic eruptions contribute to constructive forces as one of the driving agents. Molten rock is deposited through elevated openings in the Earth's crust, more commonly referred to as lava. When lava cools, it creates landforms of igneous rock in particular. This is how a lot of islands are formed. Volcanic eruptions underwater building up igneous rock until it breaks the surface of the water. Crustal deformation alludes to changes in the shape of Earth's surface, usually the result of Earth's plates colliding. This causes folds and faults. The explanation of those two terms is probably going to elongate the video to 10 minutes at least, so I'd rather not. All of these forces contribute to the process of the formation of landforms, and each are equally important to the cycle. Thanks for sticking around this long. Tell me what you think in the comments below. Did I flub any facts? Is there any particular place where I stutter for a good 0.5 seconds, or where my tone of voice sounds unnatural and choppy and just bugs the heck out of you? Do you think the final product of this video was really going to be worth 100 extra points towards a pizza party? I mean, the last question's answer is obviously yes, but... Comment your questions and opinions, I'd love to hear them. Also, check out the original script found in the description below. You can find the description right under the like button, which you should definitely give a click. It'll probably be helpful if you can't understand something that I said, because, you know, microphone quality issues. I'm broke and unemployed. Microphones are not too high on my priority list right now. Again, thanks for enduring this one-man train wreck. That will be all.